So recording started. So we saw about multiple data set, correct? At the time of examples and other thing. Multiple data set we work. We know how EDA is working. Okay, what is the purpose of EDA? Okay, we already covered up lots of assignments also for EDA, those machine learning and other thing. So today we are going to discuss about bank note authentication. Means that note of that bank is fake or not. Okay, that we will going to implement as a real case study end to end. Okay, so let's jump directly. Again, we collected this whole data set from Kaggle. Okay, so in that Kaggle, okay, if you click on this link, okay, you will get the data. So what is happening? Data were extracted from images, obviously note, bank note images, and like a genuine or forged back note. For digitization, the industrial camera usually used to print inspection was used. The final image have 400 into 400 pixel, means individual banknote that picture. Due to the object length and distance for the investigated object grayscale picture with a resolution 660 dpi were gained. Wavelet transform tool were used, means how those data are actually collected. Now obviously data collected, but for machine learning, you need to convert those data in digit. So we are using this data set because this data set, they already converted like a variance, skewness, curtices, and entropy. Like this way, they already segregated. Okay. And that class 0 means basically, forced banknote. 1 means genuine banknote. Okay. And you have, suppose like this way, your data set. Okay. Now, for EDA, okay, can you unmute once, like anyone, just unmute once.
Yes.
So Shivani unmuted. Shivani, tell me one thing, for EDA, exploratory data analysis, correct? How much time you need to do that EDA part?
Today I have completed it within 1 hour. 1 hour.
Okay. So now in practical, now we are doing practical things, correct? So if I say you for EDA, okay, to generate all the reports and everything, you need only 2 minutes, like a Maggie. Okay, how we can do that? Let's go and jump. That's why this is a practical thing. See, this data we have for EDA. The new thing that we're going to learn today, this one, Panda profiling. So you have to import Pandas profiling profile report. Okay, I just wrote 3 lines over here. I import it. I create an object, pass that data set. Okay, I given a EDA report a title, and yes, this is like explorative, so true. And I'm just wrote like profile. And what is happening? See, this is my whole report. It's automatically generated. See, like what are those duplicates? Okay, last row, first row, like a sample. This is my missing value. Okay. This matrix you created previously also, correct? Pearson matrix. This is like a variance versus skewness, how those scatter plot actually look like. Okay, that you can play around. This is individual column wise, how much correlated those data, what are those distinct. See, 0 is 762, 1 is 610. Now you can also deep dive. If you can click on toggles, see maximum length, total character, categories, okay, like this pie chart, frequency, okay, what are those words are there, characters are there. Okay, the same way you can do like for entropy. See over here, your histogram is created, correct? Maximum, 0, negative, mean. Okay, everything in a single shot only you are actually getting. Okay, how many total duplicate rows are there? Okay, everything. So you have to just click like this way and directly you can see. Cool. So that's mean your 1 hour, 2 hour job is basically just like a 3 line in practical world. Cool. So once it's done, then obviously, what was missing value change where you are actually implementing Z code or like median, that you need to do manually, that they can't help. They are just giving you the insight of data to understand so that you don't need to spend hell lot of time. Clear? So now what we are doing, we are just splitting in our x-axis and y-axis this data that we already know. I lock, correct? So via I log, I am just splitting this one. And obviously in X, we are getting variance, skewness, fluxus, and entropy because that's my dependent. And my Y means my result is basically my Y axis. Simple. We already saw trend test split, correct? How we can take the split. Here also we are giving 70% trend and 30% what? Test data. Now, first thing, here I'm directly implementing random forest classifier. Why? Because I know from my domain expertise, random forest is basically having multiple decision tree, correct? And this is basically because this is giving me some information. Here plain, simple plain will not going to work because this is like a information. So we have to gain some information. So that's why I directly using random forest classifier. But if you want to use and check with multiple others models or algorithm, you can easily implement git search CV or randomized CV. Just we learned last session, right? And you can play around with the prediction. But as I know as a domain expert, okay, so you can see after predicting and check the accuracy, first time only my score is 99% accurate. Okay, now up to this line score, we every time used our model in our last few sessions. We know that how to reach up to score. Now point is, just think. Now unmute and turn on your video, everyone. Let it be little bit interactive because as this is like a real world case study. Think, if this is your model that you train and test, you got the accuracy. Now first question is how you can reuse this model, correct? You have to store somewhere this model so that when you are creating some API, you can call this model, correct? And you get some answer. So the requirement is came how to store this model. So we can store this model in two ways. One, by default, Python is giving something in that way. Another way, scikit-learn is giving another thing in that way. Okay, let's see those two things. Then we will going to check which one is good. So, see this one, import pickle. Okay, new library we are introducing, import pickle. So in pickle format, we can store our this trained model. Okay, but you need to do very simple. See, pickle out, open. I'm giving that model name classifier. Extension is pickle. WB means I have to write. Okay, in the write mode. And I'm just dumping and I am just closing. Simple, very simple. In these three to four lines only, if I just run this code, then see what will happen. You can see one file I got, pkl file. So this is my pickle file. Okay. Another way to do that, that is scikit-learn is giving job lead. So one is pickle, another one is job lead. And what I'm doing this time? This time I'm dumping directly my another model I just used, that is like execute classifier. So this is we not yet learned, that we will check in future. So if I'm doing this one also same way, so this is give me see 99%, my train accuracy 100, so almost same. So this one I am storing as a job lead. Previously we stored as a pkl, as a pickle. This one I am storing as a job lead. Now see what is happening when we are storing. This is my job lead file, same way, but see the difference. My direct pickle file is having 369 KB, but my job lead file is having 84 KB. Now, if you are implementing this model in your system, no matter 369, 84 KB, it's perfectly okay. But think, if you are creating a robot, that robot need to predict something or classify something. You have microchip, storage space is very less. That point of time, you need something optimized. So that point of time, we will use this job lead. Else, if you have space, use pickle, no issue. You can use job lead also, no issue. Cool. So up to this clear, like how we can create a pickle file or job lead file. Very simple. Okay. Now see, this is Spider. Okay, Spider, we already know how Spider works. Okay, this is like a Python code editor only, simple, very simple code editor. Okay, that will come by default with Anaconda whenever you are installing Anaconda. So if I am opening my project in this one, see what I am doing. This is just think like this is my main. Okay, main. So I need to install these two things first. FastAPI in UVCon because I don't have. Correct. So how you can do that? You will open your Anaconda. Okay, Anaconda prompt. Okay, and from there you will just write and install. Simple. That is, once it's done, then you have to import these two. Import UVCon, import from FastAPI, import FastAPI. Okay. Till now I haven't used Pydantic. Okay. Then what are we are doing? We are creating object app FastAPI. See, @app.get, defining a function that is index. Okay, defining another function that is get method, welcome, that my route. Okay, and I'm passing something as a parameter like a query string. Okay, and if I run this, okay, if I run this, okay, let's see if I run this, what will going to happen. Let's see how we can do that, how we can run. See, this is my main, page name is main, and this app, this object name is app, correct? So what I need to write over here, like this way, UVCon space main colon app hyphen hyphen reload, and once I press enter, application startup completed. Okay, let's move to over here. Let's run docs. So we got that over here. It's running index. If I am just running index execute, see it's giving me hello world. Go back to Spider, check. It's written hello world, correct? So by default, it's giving. Now, if I'm going to another one, welcome. So if I'm giving like, suppose today is teacher day, right? So if I'm just passing as a query string, teacher thing. So it's saying, welcome to console log channel teacher thing. Why? Because I written over here, welcome to console log channel. I am passing this parameter query string over here. Correct? Very simple. And how this host and port is basically running, because we are defining over here. If we can change, it will also change. It's very simple. So up to this is clear, correct? So this is one format, okay, doc one. So that this is actually giving Swagger UI flavor. Another flavor is there, that is redoc. Another flavor is there, that is redoc in this way. Okay, so like two kind of API documentation that we can create. One is Swagger, another one is redoc. So this is called redoc. So this is also like a same, everything is same. But we can't play around over here. Okay, if I need to do, then I have to click, means copy and paste somewhere. So that's why we are playing with that docs only, sorry, not docs, because here we can try. In that redoc, we can't try. That's just a document, normal documentation. Okay. So this is very simple up to this. Now let's go back to actual thing. Okay, let me stop this server. Ready, stop. See, now it's stopped. Now again go back to jump in our app.py. See, this is the main one, main.py. That is just like a example that I created. Here, actual thing is there. How? First, you need to create a class, correct, in Python. See over here, we are using Pydantic. Okay, and we are creating a class, very basic class. Banknote, base model, 4 parameter, whatever the thing is there in our CV, the same way, variance, skewness, currency, center. Simple up to this. Now, if you go to app.py, same. You are importing Evicon, FastAPI. Now, new thing you imported, that is banknote. Now, where is that banknote? Obviously, that class you just created, that you are importing. Now, another thing is you are importing, that is import pickle, that we already saw over here. Correct? Because here we are dumping. From there, we have to load that model. So, same way, pickle. Now, again, we are creating an object. Now, in pickle, we are opening that particular pickle file in read mode. Previously, we wrote WB in a write mode. Now, this is we are opening as a read mode, which we are reading that pickle file. And we are loading that pickle in an object that is called classifier. Clear up to this? Same way, we are just testing, like, your routes, simple, like /1. Here we are passing those parameters as a query string. Now here the actual one, we are giving /predict. Okay, and we are defining a function. Over here we are passing data as banknote. Why? My banknote I created as a class, and that class will going to hold 4 parameters. That one we are passing as a parameter over here. Okay, that data, this data, whatever we are going to get, because the data is normal data, but data type till now is basically my banknote data type. Correct? That's why it's validating. We already discussed how Pydantic is doing. Now we are converting that data as a dictionary. Okay, once it's done, so obviously we know dictionary means this structure, key and value pair, dictionary. So we are assigning in a 4 variable over here. Simple, this 4 line, very simple. Up to this, nothing like fancy over there. Now, what we are doing, classifier dot predict, and we are passing whatever the data is user is giving, that we are passing over here. And we are creating a condition, means if something is beyond 50%, so that's mean we will say it's a fake note. If not, then we will say it's a bank note. Correct? And it will return a prediction, means I am returning this value I am returning like a fake note or it's a bank note. Simple. So this condition is called, okay, let me write it out over here. I forget to wrote. This is called decision boundary box. This is called decision boundary box. Means in your model, you are saying if something is beyond 50%, I will say it's a fake note. Okay. But someone can say if something is coming beyond 60%, then I will say it's a fake note. So it totally depends on you. You are giving which parameter, like 50, 60, 70, which one. So this is called a decision boundary box. Okay. So once I created this one, so let's again jump over here. See over here, we are passing this, we can pass and check like this way. Classifier dot predict 2341, whatever the value I am passing, it's keep returning me 0, means this is a fake note. Correct? So same way, classifier predict this way, and 4 parameter that we are passing, the same thing we are passing over here. See, classifier dot predict and 4 parameter. Correct? Here I'm not importing any scikit-learn or anything. Here what we are using, we trained our model in a separate Jupyter notebook file. Okay, we got that pickle file or joblib file. That pickle or joblib file you are implementing in your project. That's mean if you don't know machine learning, if you got this pickle file only or joblib file, so that's mean you know how to implement this kind of project. But this what will going to do whoever is working in your company as a full stack developer or front end guy or back end guy. Your job will be as a machine learning or data scientist. Okay, you have to create that model, you have to train that model and generate that pickle file, because those guys, they don't know. Now, if you know both the part, so obviously your value will be huge. Here also, like we know, MERN stack, mean stack. Here also, this is called full stack development. If you know EDA as a data analytics, if you know data scientist, those machine learning, another thing. If you know how to build this programming in Python for those API, and if you know the front end React, so that's mean you know the whole platform and whole stack, and you can easily implement. Now you can think, if you have an EC2 server in your cloud in AWS only, you can easily deploy this model over there. You got that API, you create a front end, done. You just pass those data, it will return you is a fake note or not a fake note. Simple. Correct? So now this time for this file, how we can write something? See, the file name is app, and I declare FastAPI object name is also app. So that's mean here I need to write this line. Uvicorn space app colon app. The first name is file name, second name is that object name. So if I run this, now it started. So let me just refresh this page. It's already open. Okay. So index, we are not checking get name that we already checked. So this is like a predict banknote. See, it's giving you the schema also for banknote. If you click, see all are like a number. You have to pass these four and all are mandatory. Why? Because in your banknote here, you given four, all are like a mandatory one. And all are like a float. So that's why they are giving like a what? Number they are giving. Correct? Now, if you can pass, now you can play around with this one. How? Click on try it out. So if I say one, I don't know what are those value. I'm just giving random value right now. Let's see. Four. If I click on execute, see it's giving me it's a banknote. I don't know. It's giving me it's a banknote. That's cool. No issue. Let's change that value. 4, 2, 3. Okay. Let's create it's one. Execute. So it's also a banknote. Okay, so which one is not a banknote? We try it over here. 2341. This is not a banknote. Okay, so let's play with that one. 2341. So this is 2341. It's giving it's a banknote. So something is happening. What is happening? Zero. Okay. Okay, let's run this one once. Let's see. Run. Okay, we can take from here also, correct? Okay, let's run it once first. Okay, so up to this is clear. Classifier pickle. Um, Here we imported classifier pickle, that one only. So it's again retrain. So let's give some existing value. Let's copy this one. This is like a variance. This one. Let's copy this one. Skewness. Let's copy this one. Okay, that execute. So it's giving it's a banknote. Okay, cool, no issue. Maybe it's a banknote. So let's copy this one. This is one different totally. Copy. Hmm. Yeah. See, now this is saying it's a fake note. So that's mean zero means this is the banknote. One means this is a fake note. Okay, and it's clear. See, this is happening. Previously, it's given like it's a banknote. Now it's given as a fake note. So that's mean now you can think like we don't know what the meaning of variance, skewness, kurtosis, entropy. That's okay. That's perfectly okay. Because note picture as a data set they can provide, and you don't know how to convert a picture to like a data. So they already converted that one. Now don't think about this one. Now think about any algorithm or any use case that you already learned. So based on that, you can easily create a pickle file. You can easily import that pickle file in a FastAPI, and you can play around with like this way only, correct? And your API is ready. Now your model is ready, API is ready, implement and play. So what are those things we learned? We learned how to do EDA in a 3 lines of code with Panda profile. Now, if you have, those outlier or other thing that we already previously saw in statistics classes, like how you need to do, like Z-score, median, and another thing, all those dealing that we already learned. We know how to create those scatter plot, histogram, other diagram, box plot, everything that we learned. We learned about all the machine learning algorithm that we learned. Then we learned k-fold cross validation if you have a small data. We learned about how you need to play with hyperparameter tuning with grid search CV or randomized CV. We learned how to build a model, okay, how to store that model as a pickle file or joblib file, and through FastAPI, how you can create an API. Right? So end to end, everything that you learn. Now, next assignment, now it will be fun because now you know how to build up to API level. Correct? Now you will start a practical machine learning project. Okay. But still, whoever still not yet submitted previous assignments, they can't use this Panda profile. They have to use those normal EDA technique. Because see, if you don't know what are those meaning of those EDS chart and data, this Panda profile is useless because you can't read. If you are used to with manual, then only you can read this automatic. Correct? So all the best. So first practical end-to-end implementation that we completed. So next week, okay, let me stop sharing my screen. Next week, we are not going to do any class. Okay, again, there will be one skip date next Sunday. Why? This 2 week means 13 days, whatever the 13 days you will going to get. Okay, you have to complete an assignment, a practical project, end to end. Okay, and that will be realistic. And everyone, whoever in this class, okay, or not present, everyone topic will be different. Why? See, this is not about me. This is about your practice. If you are not practicing, trust me, you will see things are very easy when boss is saying, correct? But when you are doing, it's really tough. So you have to do assignment first, and secondly, it will create your own portfolio because you are storing in your GitHub, correct? So you can showcase also others. Like, see, this is I implemented. So this is the time when you can say, yes, I personally implemented this machine learning model. Previously, you don't know machine learning, data science. Now you can proudly say, yes, I know data science. I can create a machine learning model. Later, we will come NLP. That will be our next topic. One NLP will done, then we will jump to deep learning.
Is the recording stopped?
Yeah.
Is the recording stopped?
No,
No,
it's still going on.
I am stopping recording. So before stop, please subscribe my channel. Okay. Because after this time, the course fee will be no more like 3,501. It will going to increase.
I have a question.
Yeah, coming. Let me stop recording. Shishwani.